Alright, so now we have the EKG. So now we have some EKG background. Ooh, and this is where I better fire up the oscilloscope. That's in the way. And we're gonna fire up this guy here. Actually, I'll put on both of them because I noticed that this digital one does a better job, even though it's a cheap piece of garbage. Well, it's not garbage. That's not nice. It's really inexpensive. These digital scopes, when I was your age, these things cost thousands. And this one on the bottom is like could be older than me. Excuse me. Well, maybe not, but these Tektronix scopes are old. When I started in 1990. All right. So let's see. Right. So for the EKG, you have the characteristic shape once again. And in this case, there's more than just the two places, right? There's different sections. So basically, you just have to say that this is called the P wave, the T wave, and just match the sections to the blood. The heart pump cycle. So briefly. So this is when the AV node is sending the signal to do this. So that's, I think, the P wave, right? And then each section, but very, very short. Also, you need to point out that the signal strength or the y-axis is in millivolts, and I think let's take a look here if the lab manual itself should be lab manual. Oh no, I rewrote. This is the original. I want the one I rewrite. So here we go. Well, this is in millivolts. You'll have to take my word for it. Well, or maybe get a better plot, or you can, even easier, go to your show them one of your final result plots here. You could zoom in on it, and this isn't labeled, but this is millivolts, right? So that's even easier, right? Just go ahead and use your own data. There's my characteristic shape. Maybe you can find a better one. Okay. What's next? Millivolts. And so our data rate study revealed a new challenge. there is a high or relatively high random background. And that's noise, and I'm going to show you that right now. In fact, I took some data. I figured out how to wire up our apparatus without getting the EKG shape. I put all the electrodes on one wrist, and I showed everybody the noise, but I realized that it was just too much now for us. So what I then did is I said, wait a minute, I got an easier way to show this off to you guys. And that's what I have here. I got a lot of crap here. Get a sense of what I'm doing. And let's back this camera up a little bit. Okay. So, we don't want these to go too far away because I want to put them back for looking at the other oscilloscope. There we go. And so this is an analog oscilloscope, and we'll play with this a bit. So basically, an oscilloscope is a time. It's a time-dependent voltmeter. It shows you voltage as a function of time, rather than just simply showing you a voltage like a voltmeter does. And there we go. So, can you see that? Yep. All right. So it has a little dot is sweeping across. And we can change how fast it's sweeping across. And it can show us. I can see where I could have other things going on here. Maybe I can do quick and dirty here. Let's see. Oops, dropped it. Let's see. I really am interested in seeing if I can show something here. I have a thing that you can't really see called a function generator, and I think it's set to show a sine wave. And yeah, look at that, it's starting to show up, just to give you a sense of what these do. And let's see, why not? Oh yeah, because I'm giving it a huge signal. And you say, well, what the heck is that? Well, watch this. Now it's looking like the Twilight Zone or something like that. But I can change how. There's a million knobs. It gets a little, you have to learn how to deal with it. So this thing here gives me, this box up here gives me a very precise output. So now the dot's going across so fast that we can't tell it's not a dot. We can't tell it's a dot anymore. It looks just like a line. But you see, there it is, moving up and down, and the voltage is up. You can change the sensitivity of it. Oops, what happened? There it goes. So now I take this off, and now I just see a dot because there's, well, make a liar out of me. We just see a dot because now there's no input to it. Although if we make it super sensitive, we might notice that there's something going on there. It's hard to say, but watch this. If I take one of these probes, and boy, what a mess here. Okay. This is a trip. Now I connect the probe, And then all of a sudden, look at that. And if I touch it, where's the camera? Oh, you can't see the other camera, sorry. So I got this probe, and if I touch it, it goes crazy. Well, not so much crazy, but the height, the amplitude gets really big. And now you notice there's something there. And in fact, it turns out that's 60 hertz. And if you think about EKGs and heart rate, 60 hertz is huge. And I tried to find out, it's really hard to learn about how EKGs work. They just talk to you about how to interpret them. So we're kind of ignoring that the 60 hertz noise is not really a factor. Somehow the transducer and the using the different electrodes eliminates that 60 hertz noise, and it's just too much. I haven't been able to think of an easy way to explain that, so I'm just going to punt on it. So we're going to just make believe that the 60 hertz noise doesn't exist. But what I want you to notice, though, that there's that 60 hertz noise. But notice that there's other wiggles. See, there's wiggles within the wiggles. And now watch this. There's even other wiggles. See them starting to come out. I can't make this any more sensitive. So that's the limit of how I can, but I might be able to get it out of the digital scope. And now, if you look even closer, the scope can't show it to us. So we'll switch up to the digital scope, and that's where we'll get this screenshot for you can show. And now let's see, this is 2 millivolts per box. So that means that these are on the order then of about half a millivolt or so, just in the air around us. Now let's see if we can get this going on. And we'll make a nice screen, because the digital scope has the advantage that you can stop it, and then we can take a shot. I can make a screenshot. In fact, this thing has a place where you can stick in a USB key. Alright, so let's unplug it from there. And we'll plug it into this guy. And we'll get late. This another nice thing is that we can get lazy, and we'll just tell this thing to auto set. And then it'll give us some starting parameters. And, oh, what's this thing looking at? The yellow one. Oh, I like that, because the yellow one is actually giving us a much nicer picture of the blue one, it's giving us a much nicer picture of random noise without the 60 hertz stuff. And so there are just wiggles upon wiggles in there. And yeah, you can even see, I don't know if this is what I have it connected to is tuning it in any way. Let's see, this is, yeah, okay, so these are, the bottom one is set at 5 millivolts per box. So you can see right off the bat there that the random noise is definitely, and now it's even bigger there at that rate, so that lower frequency stuff. So all of that stuff is out there and can be picked up by the the EKG machine. Let's see if it's going to save me this capture. How do I do a capture? Okay, USB device detected. And, save, recall. How do we do a capture? Self, no. No. Oh my, isn't that a drag? I don't know how to do it. Acquire menu? Nope. That's funny. How do I do a screenshot? It's probably right in front of me. I've seen it before and I forgot. Oh, save to USB. See, it's right in front of me. Saving wave to USB. Successful wave. What if we change? Oh, I like that. Much more dramatic, huh? Okay. Save to USB. Please wait. Okay. Let's see what we got. All right. In fact, I guess I'll table that one. I'll make you a picture at some point. So let's get this out of our way. Okay, so this picture is a dramatic. It shows there's all kinds of different frequencies. All right, so we're almost home. Oops. Procedure. So, first thing we did, just as with blood pressure, we did a data rate study. And we did 50, 100, and let's see, 250, 500. And so you show the overlay plot. And you see, look, as I go from 50 to 100, I see the characteristic shape appearing, but then 250, it somehow gets better and worse at the same time. Gets better and worse at the same time. And then 500 hertz looks like a disaster. Right. So, and then we look at the noise plot that I just showed. And let's see, what's the time here? That's pretty high frequency, but there are random wiggles, and at all frequencies, this is actually called white noise. And as we go to higher sampling rate, we allow more and more noise in. More and more noise in. So we need to filter out the high frequency noise, or we need to filter out as much noise as possible, and luckily and most of it is at higher frequency than the EKG itself. EKG, remember, is sort of about, excuse me, so the time for a whole one is, they repeat every 17 milliseconds. About, that's 60 hertz. So, you need at least 250 to 500. So this is 17 milliseconds is 60 hertz. So heart rates are like anywhere from 60 to, say, resting heart rate 60 to 90 or so. So we need to get rid of everything that's above, say, 100, above 90 or so. But we also need, though, we really need, that really shows you we need the 500 hertz, really. We need 500 hertz, though. So how do we do it? So we use, without getting too much into it. Oh, of course. Sorry, Layla. Wow, sorry. How's that? Oh man, my back hurts. I'm sitting still too much, but thank you. Just, yeah, of course, no worries. Kind of a waste of everybody's time if you guys don't all get it. I mean, if I move so fast, it's kind of dumb. Excuse me. All right, so I'm gonna see if someone tells me to go back. We used a moving average. An example is COVID rates, COVID cases, right? We did a 14-day average. So what happens is, in a nutshell, without getting into it, it removes the higher frequencies, which is also means that it removes the point-to-point fluctuations. And fluctuations. So if you look at the COVID data, so you'll see some days it's like that, And then another day it's like this, and there's these random number fluctuations, but well, they're quasi-random. Without getting too deeply. But when they take the 14-day average, you see this nice smooth shapes. So then you have to explain exactly what the moving average is. So we have our example right here. And this is all in one of the videos, if you don't remember. It didn't get the... What's going on? How about keep source formatting? Okay. I thought putting it up there as a picture would have been good enough. And, this is crude. It doesn't have the lines. But in a nutshell, this here, and I think this is 10. Let's see. 1, 2, 3, 4, 6, 7, 8, 9, 10. Yeah. So this one, I guess. Wow. Okay, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So each one of these is the average of 0 to 9, for maybe. It depends on if you did 10 or 8 or whatever. And then the next one is the average of 1 through 10, for example. And it's both of them. This is the T's, and this one is the voltages. And that's why it's called a moving average. And then the third one, let's use a different color. The third one is going to be the average of 2 through 11, for example. So let's see. This is procedure. Yep, we decided to use a moving average. Oh, right. So first, we plotted the 500 megahertz, the 500 hertz data. We used a trend line, moving average. To decide whether to do 6 or 8 or 10. And then you say, here is the result right here. So you have the 500 hertz. You have the trend line. This is all in the video. Then we created this table of numbers right here. So here is the 500 hertz with trend line. Appropriately cleaned up. And then this is the my average data. And that comes from this column over here. In fact, let's take a screenshot of that. Here we go. Save. Show in folder. Maybe you'll show in folder. Mouse. All right. In fact, I should put that in the slides too. That's what I'll do. All right, let me look at my notes. Ah, right. So, let me hold on a minute. So I guess, when I think about it, yeah, that's our procedure. So maybe this part, can I select this? What happens? All right. Cut. Paste. And, okay. Yeah, because I think this goes in analysis. Paste. All right, so let's see. We plotted to decide on how many. Then we constructed our own moving average table. And then we plotted this. And then we did the vertical lines, the vertical timelines to measure the QR, etc., and also heart rate. So then we have, we were in analysis and results. I know we were still in procedure, right? Procedure. Let's see. We used the moving average. Right. That's still procedure. All right, so then you have analysis and results. So we have, I don't know if I have in this file the, let's go back. See, at the end here, data rate study overlay plot, right? So then, analysis, results. Oh, look at the time. Okay, so we have the data rate overlay. And then we show, the reader can see as we go from 50 to 100 to 250, we begin to see the characteristic shape. but 250, not as good as we thought. And then you say, well, at 500, it looks like a disaster. But so we have the noise plot, and we say, well, the high. Notice this is the higher sampling rate brings more in. And so the moving average excludes the high frequency stuff, but it requires many data points. It requires and without going into detail, it requires a high sampling rate without going into detail. I tried, but I can't to retain the characteristic shape. So you're just saying that without proof. So we use the 500 hertz. So here is the 500 hertz, and then here is the trend line, and from the trend line we decided, say in 8, I think we thought we liked 10 better. So see, there is the at least the 500 hertz with the trend line. Here is our moving average. So the trend line told us because this, if you don't have there, I couldn't figure out a way to set a parameter like 8, 10, whatever, and have these numbers change automatically. I couldn't figure it out. So you don't want to be messing with making a bazillion of these. So 8 or 10 works. And then we have these vertical lines. And if you go ahead and look at the videos, you'll see how I set this up. The better EKG analysis. So you can, and I have this offset number, which is neat. So I have this set up where I play around where begin P wave, begin QRS, for example, and then basically they should stay the same. So then I just type in an offset to move it to the next one and just tweak it a little bit till it fits. So then you could take you could look at a few different ones. I suppose you could also make a separate ones for heart rate. I'm leaving a little bit up to you guys. And then how to put these on the plot, it's explained in the video. And then the manual has these tables to fill in. And remember, don't use the tables in the manual. Just let's see. No, I'm just about. There's just one more thing left, right? Let's see, where is that? The lab manual rewrite. There's a few questions here. Let's see. Right, you're not doing this. You're not doing this. This is all for the blood pressure. Not using these. And then, yeah. You're not using those tables, but measure, it says here, measure the beginning of QRX, and just, that's another, we could measure several of them, but this is, we got to keep this from going open-ended. Just like measure one or two of the QRS complexes, and then say, did you get a time between 0.12 and 0.2 seconds? And then there's another interval here. How does it compare to what's normal? At this point, it's just been so much work. I don't want you to. So that was what? Questions 7 and 8. Comment on questions 7 and 8. I have the EKG part of the manual. But no other questions. No. You're just reporting on it's basically about reporting on the data smoothing. What time is it? Okay, so I gave you a sort of introduction in oscilloscopes. I think that this went longer than I thought, and I want you guys to focus on this. So get those pre-labs working. Yeah, it's taking a long time to save, so I have to do some. It's really huge now with all the handwriting, so I have to massage it down, and I'll post it for you guys. Okay. Right. So I'd like to see the report done by next Sunday, but you guys let me know how it's going. Don't forget, you can work in groups. You have me to ask questions of, and also remember that I have these, every little step of the EKG analysis is in this better EKG that I'll walk you through step by step to produce this final graphs here. Okay. Any other questions? Sure. That would be here. Yeah, you're right. I went too fast on that one. Come on. There it is. Oh, while you guys are looking at that, I'll see if I can, what these things I put on the USB key look like. Excuse me. Guess not. Oh well. There's nothing there. Odd. It said it was downloading. Wonder what happened. Okay, so I'm gonna keep trying to download this great plot here. Fast waveform capture. So if you don't have any other questions, you can take off. But also if you want to hang out, I'll send out what I can get out of this thing if I'm successful.